Okay, hi everyone. Thanks for coming and for watching. So this is the third live coding session on Gimbal Labs using GameChanger wallet. And well, like always, we're going to start here, and we will be asking ourselves this question. So do we have a non-burner GameChanger wallet on pre-production testnet ready with testnet ADA there? So if the answer is no, we are going to experience the amazing onboarding experience of the master of the gift wallets, Quasar, that loves gift wallets and playing with the QR code encrypted wallets of GameChanger wallet. So he is going to onboard you and help to prepare your wallets with testnet data. So then you can or stay with him, like trying all the UI features of the wallet, or maybe you can try to jump into the other room where we are going to be coding and doing some more nerdy stuff. So the other room is the main room, sorry. Yes, Faison?
Yeah, I was having a query. Am I audible?
Sorry, you ask if we can hear you?
No, I am audible.
I'm sorry, I cannot hear you well. You are?
Okay, I have a game changer wallet,
Yes.
but it's on a main net. It's not on pre-production.
So if you know the dynamics or on how to load any Cardano wallet with testnet ADA using, for example, the official Cardano faucet, please can you do that on the beta version of the wallet? To go to the beta version of the wallet, you can go here. You can click here on this link on the mirror board.
Okay.
And if you feel that you maybe need more onboarding, at least stay some minutes on Quasar's room, and then you can maybe come back here. So yes, that's so the I have a little sad announcement that because I am doing a lot of work on the beta, I had to disable this nice magical airdrop of testnet ADA and tokens that we have on GameChanger. So currently, this airdrop is disabled. So we are going to be using the faucet, the official Cardano faucet for this. So if anyone has trouble with this, funding a wallet to start using it on the beta, on the pre-production testnet, go to Quasars. Okay?
Okay.
Okay, thanks.
Thank you.
So the question, you pick the room, right? The right door. So we are going to start right away with our main session. I don't know if we have already the breakout room created, Q, or
I don't actually think we were going to do a breakout room today. I don't think it's established, and I don't think we need it. Faison has a game changer on mainnet, so he's familiar, and we can just send I sent him a referral link, or I shared a referral link with anyone and everyone in the chat, and this is for a testnet pre-prod, and it does have the referral link because I'll show you some really cool stuff later, with that on how to build a treasury or do more than, personalized incentives. There's some cool stuff with it. So drop your QR code or address on the Miro, and I can send some ADA around to everyone. Test data, that is.
Okay, cool. Thanks you. So it's good to stay with you today on the main room. Okay, let's start right now because we have not much time and a lot to cover today. So Roberto Mayen and Martin Menier and Quasar, because of different projects or ideas that all these friends has, we're asking how to mint on GameChanger. Some are interested in NFTs, maybe some other on tokens. And so today we're going to start with a very basic concept, a very basic requirement to end up minting NFTs on Cardano, on GameChanger, by code. And well, then, I mean, we are going to go gradually until we end up minting NFTs. And if we don't manage to do this today, we will end what's missing the next live session. So today I'm going to do a very basic distinction on Ethereum and Cardano to get started very quickly, and this is to maybe onboard non-Cardano people on this video very quickly. So on the Ethereum world, everything happens through smart contracts, okay? So if you want to store data, if you want to mint NFTs, tokens, and do much more stuff, building, I don't know, decentralized exchanges or a lot of other applications, you need to pass through a smart contract. This is the design on the Ethereum blockchain. On Cardano, and this is what I think it's very cool design principle on Cardano, is that we don't need smart contracts to do it all. Cardano speaks natively in, for example, all these concepts. I mean, not in this one, sorry, but on data, tokens, smart contracts, and much more other stuff. So, I mean, the only thing we can do maybe on Ethereum is to interact with smart contracts directly. And here we can directly interact with Cardano with data, tokens, smart contracts, and other stuff. And of course, we can relate other concepts to smart contracts. Okay, well, this relationship there, sorry for the ugly drawings. So with having this in mind, GameChanger loves this concept of Cardano and allows you to benefit from it, to use these different features that you can use on Cardano, maybe in an individual separated way, or maybe start combining them, like many other systems, many other, for example, DApps or even some other maybe wallet use cases. But in this case, with GameChanger, you have the ability to mix all these concepts through code right within the wallet. And of course, on the app connector that we introduced the last session. Okay? So we're going to start on this one. When I say data, I mean the most use, the most basic or famous use case for data and for feature for storing data on Cardano is called metadata. Okay, so we are going to do this first exercise, that is storing metadata on Cardano. We're going to be filling this code here, and then we are of course like building, or it's not compiling, but like building the final link to, with a click, try this exercise. Okay, so let's go right straight to our last exercise, that was just creating a payment. Okay, we were creating a payment on this wallet scripting language. Actually, this was the output, the feature we were using of Cardano, let's say, to make payments. So very quickly, remember, we have some other stuff here, like the title, description. This has to do with the app connector. So with this pop-up here, we are talking about this title and this description. And we are later going to talk about another title and another description that are completely different things. I'm going to clarify this right now so it's more clear. Okay, this was the part of the code that builds a transaction. So every time we need to write information to interact with the blockchain, we need to build a transaction. When we say transaction, on other systems, we associate this with payments. And this is not entirely true. On Cardano, we can add a lot of other native features, like the ones I showed you on that graph at the beginning, like data, tokens, NFTs, maybe staking, maybe smart contracts. All these native features that Cardano offered to us are used through transactions, are interacted, are saved or stored or used on the blockchain through transactions. So this is why, for example, we have here one of these features. There is a list of outputs, a list of payments, if we want to watch them that way. We are going to go right to the feature that we care about, in this case. Sorry, I'm going to copy paste here. Sometimes I forget the exact name of the of the reserved words. So to go quickly, I copy paste. Okay, so this is the name of the property on this scripting language that allow us to start storing information, arbitrary data on Cardano. The way we can do this, I mean, the way we need to do this is by using JSON objects. Okay, please, for those who don't know what JSON is, maybe we are going to add some resources later for you to go and search. But basically, everything you're watching here, like for example, this thing here is a JSON object, this thing here is a JSON object. So it's the same structure. The rule to use this way of writing data on Cardano is to create these objects with numerical keys here. This is the key, and this is the value of this JSON object. we need to store here numbers, only numbers. And of course, there is a limit. I don't remember the maximum amount here we can use, but there is a limit, and we need to add numbers here. This is called metadatum labels. Okay, and then here we can store arbitrary information. Here's where we have the liberty, the freedom to do what we want or what we need, to store what we want. Cardano transactions, like on any other or most other blockchains, are limited in size. So we are going to be able to store here a lot of bytes, a lot of information, but not too much. Like, for example, in entire files, huge files like songs, full images, that's not possible. But we can still store a lot of information on Cardano. This is very, very cool. And prior to smart contracts and prior to a lot of stuff, you don't have an idea how much power you have on your hands by storing information here. You can do a lot. Of course, we can be a bit creative here and start relating this information to the apps, to some use cases, but this is very powerful from Cardano. Okay, we are going to go directly to use a standard on Cardano that allow us to pass messages, to write text messages on Cardano transactions. Okay, so when I say standards, sometimes people fix decides to use a common number here and a common format here to establish a standard to make other, for example, wallets to understand this information. So here we're going to be using the standard for passing messages. The recipe is this one. The recipe is this one, is to create an object here inside this metadatum label, and here a list of strings, and this is a bit technical, but this is a very common pattern to find on Cardano metadata that is splitting texts in this thing called lists. So, for example, I think we can still do this. I'm not sure if the standard allows us. I think we can. Maybe we can try. But we can pass here a message here this way as a simple string, simple text. But if this text get very long, we need to split it. Otherwise, this is going to fail. This transaction, the building of this transaction is going to fail. So we are going to say, for example, we're going to split this text into these two pieces. This piece and this other piece inside this format that represents a list of texts. Okay, so, and remember, we have a payment here configured to send 5 ADAs to this other address. I'm going to let this here just to try out that we can combine these features all together. Okay, this is very powerful from Cardano. If I click run and I click continue, I input my password. I click continue here. We can check here on the metadata. We can check on the metadata that our structure here is included. Okay. Also, we have this other structure here that is a common structure used on GameChanger wallet to keep some track on the transactions, on the version of the transaction, and other stuff like, for example, titles and descriptions used on GameChanger wallet. And I'm going to show you later. So I will click yes. The question was if we want to sign this, we can review the transaction and click yes. And well, now we are waiting here for this transaction to get included on the blockchain. Because I'm very impatient, I'm going to click here with to open a new tab on the browser to open this transaction, to watch this transaction, I mean the state of this transaction, and we can check that our friendly backends from Dandelion are serving us already the information that this transaction has been included on the blockchain, and we have all this information from the transaction to view, to audit, because this is already stored on Cardano blockchain. And of course, we have the message here. Well, we could add here a space, but we have the transaction here with the message. Also, this is new from the beta. If we, for example, go to start, and if I go to the list of transactions, well, my computer is a bit slow. Okay, here. This is new. We can check the message right from here. A message from GameChanger. Okay, so we go back to our coding place, and we have, this succeeded. This is the returning information from the script. We don't care much about it right now. So we've done it. We have stored information on metadata. This is a standard, but we can change this number, change this information here, and we can be storing a lot of stuff, different stuff. So very quickly, I'm going to show you. Wait, I'm going to. Okay, I'm going to show you also some other metadata that we handle on GameChanger wallets. That is adding a title and a description here. inside the definition of a transaction. Okay, remember the type build transaction of this function, of the scripting language allow us to build a transaction. Then, of course, we call another function that is sign transactions and another one that is submit transactions to actually sign the build transaction and then submit the transaction. Okay, so I'm going to see here message transaction. Okay. Please check the difference between this title and description and this title and description here. These ones here are going to be stored in the metadata of the transaction as well. But these ones here are native to GameChanger Wallet, are specific to GameChanger Wallet. This title and description gets stored on this standard, this piece of metadata that I've showed you before. That is a pure and exclusive GameChanger standard. Okay, so now, and I'm going to, for example, show you that you can even do this transaction to your own without any payments. Just store the data and that's it. So we can do very cheap transactions to just store data. We don't have to make a payment as a requisite, I mean, as a dependency. So that's it. I'm going to run this and I will click continue. And here we can see that the transaction review here show us already as title and as description the title and description that I showed you that is going to be included on the transaction metadata. Okay, message transaction and transaction with a message. Okay, and check this out. As spending here, we're just spending this little ADA because it's just the fee. This transaction has no other output to any other wallet, so we're not spending anything else. We're just spending the fee, the network fee, to write these messages, these texts on the blockchain. If we check the metadata here, we can see first that we have the message that we created originally, like we created this by hand. And then this thing here that remember is a GameChanger standard that stores some metadata stuff, is storing the title and the description we just added to this transaction. Okay, so if I click yes, we now are going to wait for this transaction to get included on the blockchain. And when we watch this yellow or maybe white, then colors, it means that the transaction is okay. It has been included. Okay. So because I am impatient, I'm going to open this on a new tab as well. Well, we have to wait. Maybe we can check this on an external service, this Cardano Explorer. That is Cardano Scan. Oh, okay. We are faster than Cardano blockchain. It's not included yet. Now it is. Okay. So there is a lot of information here. I don't want to get you all confused, but you can check here that this is the message we stored, okay, on that standard metadata standard. And if we check on the metadata, we have also, we have these two metadata labels. This is the raw format for the message that we have seen here. And then we have this description and this title, okay, that we added. Okay, and in GameChanger, you can check this here, message transaction. This is the title. In GameChanger, we find here the title and the description that we added, we included. And if we go, for example, once again to the beginning, to the start of the we can see the actual title shown here. This is why we have this standard on GameChanger, because if we keep having these abstract generic titles on our wallets, we actually don't know what those are all about. But if we can put titles to our transactions, we can track them. We can understand what is this transaction about. This one was the last one, and this is the title that we included. Of course, we have the message here as well. Okay, we have covered this exercise already. Okay, and like always, I'm going to copy here, the link for everyone then to try out. Okay, quickly, is there any questions so we can jump to this other exercise? Sorry if I go a bit fast, but there is so much to cover that we need to.
Adriano, I think Roberto has a question. So let's jump to that.
Perfect.
Thank you guys. So Adriano, just a quick question. If you had to generalize, where is there an echo? What would be the steps that you would follow, that you suggest we follow to build a transaction? Because I see there's functions, and then there are metadata standards that you include within the transaction. So if we know the standard, what I understand is you just build the standard inside of the transaction. And then how do we know how to run those? Where do they go, and when do you need to like instantiate functions or build functions, and which are functions, and how do you know which functions to use? Or so how would you go about like step by step? What would be the steps that you would suggest if I wanted to build one of these transactions on my own, like a different transaction on my own? You know what I mean?
Okay, Roberto. Okay. I guess I understand the question. So yeah, this has to do with our first session. Okay, this layout we have here. On our first session, the last Tuesday, we covered the very basics, this very basic layout on the code that allow us from start to end to create a transaction and to include it on the blockchain, on Cardano. These are 3 basic steps that are common to any system on any, I mean, at least on Cardano, I will say, where we have a stage where we build the transaction. Okay, we design all these features in a way that Cardano blockchain will understand them. This, this insight generates like a piece of data, of hexadecimal data, that then we can, keep processing with some other stuff, and then we send this exact data to the Cardano nodes that are going to validate them and are going to then include these transactions on the blockchain. So this is the first stage of this common pattern we have to do always, build the transaction. Then is the signing part, is where when we build this transaction, and we will cover everything here in detail in the future. It's too much to cover right now. But when we build these Cardano transactions, we create like tiny placeholders, like tiny buckets, tiny boxes inside the transaction that are meant to be filled then with our signatures. We have this private key concept on blockchains, on cryptocurrencies, where without our signatures on these transactions, on any transaction, the transaction cannot be spent. Our funds cannot be spent. So here is where that magic happens. Okay, this piece of this basic pattern takes care of finding those placeholders, those boxes, to identify which private keys of my wallet, or maybe others' wallets. This is a multi-sig case, for example. These placeholders are identified, and if you have the right private keys, this part of the code attach these signatures using your private keys to the former transaction data built here. So in this way, you are saying, yes, this transaction is approved by me, by my wallet, by my private keys. So we can use my funds, you can use my private keys to, for example, mint a token, mint an NFT, etc., etc. So this is the second part. And the last part is a very simple part. We have the signed transaction, okay, this piece of data that now has no empty placeholders, it has the signatures. Now all this data needs to be sent to the blockchain, because if I don't add this last step, nobody, the Cardano blockchain will never know we are willing to spend these funds, we're willing to store this metadata on the blockchain. Okay, so without this part, we are not doing actually anything. With this last part, we are communicating the entire network of Cardano nodes that a new transaction is ready to be included, validated by the nodes and included. This is the basic pattern for doing this basic thing. Send a transaction to Cardano, okay? What's nice about this scripting language is that you can do a lot of stuff. For example, you can create maybe another transaction and maybe another one, and then sign them all together. Or maybe you can build a transaction here that is a multi-sig transaction. So these two parts maybe are not executed on this wallet. So we can maybe just export this transaction data to another wallet to be signed, you know? This is up to you. I cannot tell you exactly what pattern, what design of these codes is the best one, because it's up to you. It's like, okay, you are now a developer. So I can give you these basic recipes, but you can start playing with them, modifying them, and achieving your own goals, okay? Roberto, your question has been asked, responded?
Yeah, thank you. I think, I'm sorry, I missed the previous live code. And so if I understand you correctly, the main functions are run, and inside of run, you can use build, sign, and build pretty much is the off-chain part of the transaction, where you can include metadata and all the other, and yeah. Okay. I think I get it. Thank you.
Please watch our first session. There you are introduced to the syntax, okay? So you are going to be understanding why we are nesting things inside run and what this actually is, because this is arbitrary text. What's not arbitrary is this, for example, okay? These are the reserved keywords of the language. Please watch that video, and then we can discuss maybe more questions. But yeah.
Okay. Thank you.
Okay. No problem. So any other question? We can move forward. Okay. So now we are going to cover this one, how to mint a token. Okay. So for this one, okay. So for this one, of course, we are going to start from our previous example, but I'm going to remove this. No, I'm not going to remove. Sorry, we are going to still be attaching metadata, just to remember that we can combine all these features together. Because if we start thinking on this individually, we are losing all the fun. The nice thing about this is that we can start combining stuff all together on the same transaction, okay? So now we are going to use the mints feature to mint a new token. So wait, I'm going to start from here, from a demo. Remember, on demos, we have a lot of demos, a lot of examples. I like to start from these demos to keep the syntax okay, and to also, you know, go a bit faster. So I'm going to copy this structure here. Bear with me, we are going to keep it I mean, a bit simpler in a second, but we're going to create, we're going to mint a token, okay? Like tokens are like, you know, like sub coins inside a blockchain. We have our official main coin that is used by the network, that is ADA, you know, Cardano. But we can create sub coins called tokens. Coins, and these tokens can maybe be something else. So we are going to say native assets, actually, not just tokens. Okay, native asset is the right category that that groups all these things we can have, like NFTs, tokens, semi-fungible tokens, fungible tokens, etc. So the very basics to identify a token Okay, the very basics to identify a token is, and we can check this on GameChanger wallet, when you have already some tokens there, are these two things, are these two things here, the asset name and the policy ID, okay? So if you have an asset name and you have a policy ID, you are referring to a token. Every token being minted or created on Cardano can be found using these two pieces of information. One is a name. One is just a name that we can use, okay? And the other one is a hash, is an hexadecimal representation of the minting policy. The minting policy is the rule that we can have, that we can use to allow further minting or maybe burning of these tokens, of these assets, okay? And this is important because one of the most basic concepts inside or around minting policies are our private keys. Because if anyone can mint a token, what makes it special? What makes it unique or maybe valid enough to be used or trustable enough? So we can relate our private keys, okay, our private keys, our wallet private keys, to the minting policy of a token, saying this simple, basic thing. If I'm not me, no one else can mint my tokens, okay? This is the very basic thing regarding minting, this minting policy. Another thing that you can add here on these policies is time. So you can say, I'm going to be able to mint these tokens until, I don't know, some day in the future. So then, for example, we can have tokens with a limited supply forever, enforced by Cardano blockchain, okay, as a guarantee that no one is going to be able to mint those ever again. All these things, and much, much more, because here we can, in the future, relate this to smart contracts. All these things are minting policies. So when we have a minting policy, as a piece of data when we are able to build, to materialize these minting policies in a piece of data, okay, when then we can extract like a code, a hash out of this piece of data that turns into a policy ID, the famous thing we have been reading all this time on all these native assets in Peruana. This is a code representing a minting policy. Okay, so let's do this. Let's create a fake USD token, because why not? And let's, for example, let's create like, wait, I don't know if I have this token already. Let's do, I mean, on my wallet, let's do a fake gimbal token. Okay, so and let's create 100 of these tokens. Okay, following this structure. Remember, this is the definition of the transaction. Here we have the metadata that it has nothing to do with what we are doing, but we can keep it here. And then we have the definition of the mints. And here, this is a list. This is a list, so I can, this is a list, so I can start adding items like this one. Okay, different items. To mint more than one stuff. So on the policy ID, we need to pass here this strange hexadecimal code, but for having this first, we need to actually create a minting policy, okay? And then I'm going to leave here this piece of code. We are going to be using it later. And then on, I mean, this was the policy ID. And on assets, here we define the exact assets that we are going to be minting under this policy. Okay? And remember the name, fake gimbal, and the quantity. This is the structure we have to follow. If I run this, it's going to fail because there are a lot of issues. Here, of course, this code leads to nothing already. So we don't have a policy ID yet. And also, we need to provide the transaction with the actual minting policy. Okay? It's not enough to have this hash, this representation of the minting policy. We need to also provide the minting policy itself. And remember this when we talk about hashes of these, for example, hexadecimal codes out of other pieces of data. With just the hash, we are not able to retrieve the full data behind. Okay? So when we talk about a policy ID, it's okay, we can refer to a minting policy, but that minting policy has to exist somewhere. Okay? It's not enough to just use the hash. For this instance, in this instance, when we create a transaction, for example, we need to provide the actual full entire minting policy. Okay? So that thing is also, I'm going to do it from scratch. Okay, that piece of data is, of information is also missing from the transaction. And I'm going to mock it to add it now here. So okay. Well, I'm going to leave that there. So When we need to attach minting policies, for example, there are much more stuff that we can do with this. But when we need to attach these minting policies, we add it to a place on the transactions that is called witnesses. Okay? And there are two ways to have minting policies on Cardano today, up to today. Two ways. Using smart contracts, that is a much complicated thing to cover right now, but also we can use dump contracts. Yes, I call them dump, but they are very cool as well. These dump contracts are not as capable as smart contracts, but these are very limited in functions, but are very powerful indeed. You can do a lot of basic stuff. These dump contracts, and please don't call them dump outside these live sessions because people is going to burn you alive. These dump contracts are actually called native scripts on Cardano. Native scripts. This is why we have the native script text here. We are adding on witnesses a native script. Remember, on this scripting language, we can add arbitrary naming to the pieces of our code. In this case, we call this minting script, just because we want to. Okay, this is arbitrary text. Okay, this is not arbitrary. This is not arbitrary. This is not. These are the reserved keywords of the language. And it's not magic, you can check all of those here on the documentation. Maybe we are going to explore the documentation another day in deep, so you can find actually where all this stuff is coming from. But remember, these are reserved keywords and this is not. And here we have to pass also an hexadecimal representation of our entire minting policy. To materialize this minting policy, we are going to use a native script, a dump script. Okay, so I'm going to explain this later and adapt this piece of code later. So we have this basic layout now. We need to construct our first minting policy. Okay. To do this, if you remember the first example of code we coded on our first sessions, we were asking the wallet for our address, right? So okay, so arbitrary naming, this stage of the code is going to ask for a user's, our current, address. Okay, and then, and don't worry, I know I'm going very fast. We're going to test this. Before we're going to say info here. We're going to say address. There are a lot of ways to do this, to achieve this. This is one of the ways I like to do it. Okay, because it also gives you the ability to start understanding how Cardano works. It's a bit hard maybe at the beginning, but then when you understand it, it gives you wings. So the magic trick here that we're going to be doing is this one. Our address, our Cardano address, for example, the one we can copy paste here, the one we can explore on this list. Okay, we have this address as current address, the one that we are using. The address that is being shown here, all these funds, lies inside this address. If we go to discover, and if we go, for example, to keys, we are going to find out that our current, and I'm changing my current address here, the address I'm using. I'm switching wallets, let's say, within my same mnemonic wallet. These are child addresses. Each of these child addresses has different keys. You can check behind that every time I select another address, another set of keys. This is the list of keys of my wallet. If I change here from address to another address, also the private keys that are used inside the wallet change, or at least I need to change and start using another private keys. Each address comes from our private keys. And if I can have a lot of child private keys on my wallet, I can have a lot of addresses out of each of these keys. I'm going super fast, but this is the basic concept around all these crypto wallets. So what you're saying, Adrian, what I'm saying is that my address is a representation of my actual keys, my actual private keys. So what if I decode this address to obtain a reference, a hash of the private key that I'm using on my wallet? So, on other terms, I can use the address to know which private key is behind my address. Okay? Quasar, go ahead.
Oh, I didn't realize you'd see my hand so quickly. Since we're coming up on like the last 15 minutes, I've got a ton of questions for you, or like where you are right now. However, I'd like to defer it to the community and the people here in attendance, for you guys to have a chance to ask questions for these last 15 minutes. And I didn't mean to interrupt you, Adriano, but honestly, with what you just dropped, I think there's a lot of questions that a lot of people have or will have. So does anybody have anything?
I mean, it's perfect to have questions. I know there are questions there, and if not, we are maybe wrong in something. But what I want to finalize the example.
Go ahead. I'm sorry to interrupt you.
No, it's okay. It's perfect. Thanks. Okay. But I want to end up with something usable and runnable, executable, so you can then check it, and maybe on the next session, if we don't have enough time now, we can make a pause and do all the questions and make more deep dives inside the code. Because
wonderful.
This is infinite. So if we go very, very slow and we don't have questions because we're going slow, I mean, it's okay, we can do that approach, but I prefer to give you examples and to cover them on recorded video so you can then check them out and ask all the questions later, and we can have maybe full questions dedicated sessions. Okay?
Fantastic. That sounds good. Thank you.
No, thanks to you. So, I mean, let's try this out on a different. Sorry for this back and forth. To go step by step. Let's run the same code without all the transaction building stuff and all this complexity. Just our first part here, the trick that we can do with the others. I'm going to explain this. Remember, we have this tiny language, coding language inside this thing called macro, these macros, where we can run some set of functions here to do some useful things. In this case, we have a very common used function that is get address info. Okay. This function will decode a Cardano address for us. The code will analyze it and give us a lot of information about it. So, if I need to pass here. Oh, I need to now, inside this function, I need to pass the result of this line, this piece of the code. We say, remember from our last coding sessions, cache dot address. So, I'm very sorry. That's it. So, inside as an argument of this get address info function, we need to pass the result of the address result that was asking for our current address. Okay, so if we run this, and we return with the data, remember inside data we have all the results of the script. The result of the address part goes here, and we have our current address. And here we have a lot of information on address info. We have a lot of information out of our current address. This function has decoded our Cardano address and is giving us all this information ready to be used for us. Here we have the famous reference to our private key. But for our spending private key, let's say, the private key that allows us to spend our funds. because here we have the staking the reference of our staking private key, the private key that allow us to stake, to delegate our funds. These two pieces of information are the actual information contained inside our address. Our Cardano addresses are made out of these two hashes that are references to our private keys. This is the secret out of Cardano addresses. And what we need to do is to reuse this hash on the code, on the minting policy, to force the minting to just be able to mint, to create new tokens if we are using on that transaction, if we are signing that transaction with this private key behind this hash. Okay, so this is the property inside address info that we need to look for. Okay, so then we can say, anyways, so now in the same fashion that we can run a macro, for example, to get information of the address, we can just use a macro to isolate, to give us the exact piece of information we want under a tag, a name. That is this one, minting key hash. And what we are actually doing is using this get function once again to get the result of address info, and what address info was delivering us inside, that was this payment key hash property. If I run the code, this was already explained, this was already explained as well, and here we have a new result, minting key hash. And we have the exact same information, like copy-pasted here, ready for us to be used. Okay? So if I go back to our previous code and I insert these 3 lines here, we have our minting key hash here ready to be used. Now, once again, I'm going to go a bit fast here. Remember, I want to end the example. Then we can have questions maybe on the next live session, just to make sense of this time. And this, we don't care about this. And that's it. So once again, remember, we have here our minting key hash, the reference to our private key with the one we are going to be minting. Here we are finally creating our minting policy, the native script, the dump smart, not smart, the dump contract we're going to be using is of type native script. Okay, and here on this property we define the script. Bear with me, we're just going to be using a very simple feature here, that is the issuer feature, that is going to be locking or enforcing that only a private key can be used this native script. We say this, we add this reserved keyword called pubkey hash x, and here using a macro we can get what we have already isolated here on this result under this name, minting key hash, and that's it. And going back to this example, this tiny piece of code that was just getting the basic information. Okay, if we run this, we have an error. Sorry. Maybe I need the script out. Okay, just because of the time I will be doing this. Then, no, wait. Sorry, sometimes I forget the exact syntax. This language is so new that, of course, I don't remember it, you know, as if it would be like JavaScript or something like that. So, this should work. Yes, it got validated. So, we even get the code, I mean, even more simpler. Inside the script definition, we are just using the pubkey hash x property to reference a private key. If I run this, I get the address info, the minting key hash, and now this new line here, this new section that was the minting policy, that give us these free, ready-to-use pieces of data. The script hash x for hexadecimal, but the script hash, that is this piece of data, and the script x, this piece of data. This one that I'm marking here is our actual native script. And this one here is the hash of the native script. The hash of the native script was the famous policy ID. Okay? So, okay, I was going very, very fast. It's okay to have doubts. It's too little time. We have no more time for today. But with these pieces that we have here, like in 5 seconds more, we can have our first minted tokens. Maybe we can retake from here on the next live session. I'm going to be saving this on the mirror board, and remember, it's not going to work. We need to connect this part here and this part here to what we have done already, and that's it. And it's going to work. It's okay if it's too much, believe me. We are going to make a proper pause the next time to cover all the questions. It's somewhere there.
All right. Well, hey, thank you, Adrian. Thank you all for attending, for the questions, and we will definitely execute this contract next week, maybe even before, to see what it looks like and come back to it. But on behalf of Gimbal Labs, GameChanger, and TuTech, thank you all. And we'll see you on a Twitter space right after this if you'd like to join us. Adriano, thank you so much.
Thanks all for for being this. Sorry for being this fast, but it's too much. We have to keep a rhythm here. Thanks, Kip, and thanks everyone for attending.
Thanks.
Join our
See you soon.
Twitter space.